Hello, everyone. Thanks for joining me today on this webinar. My name is Fatima Bashir first. I'm an urban water engineer at DHI New Zealand. And today I'll be giving you a run through a tool that we have at DHI, which is called WaterNet Advisor. And that is basically a web-based application that can allow decision makers to get quick answers regarding the conditions of their water distribution network. So just an overview about what we will cover today. So first of all, I'll start by giving an introduction about WaterNet Advisor, describing what it is and how it actually works. I'll run through the different scenarios that we can use in our system. Also, we'll go through live demos, and then I'll talk about WD Online, which is the online water modeling, water distribution modeling, and then a bit of a summary about everything. So what is WaterNet Advisor? So WaterNet Advisor is basically a smart interface that will help a decision maker, whether that person is an engineer, a planner, or a manager, to perform quick tasks in order to access their water distribution network and make quick and easy decisions. There is no need to be a modeler or to have technical skills in order to access your models through different softwares, and it just allows you to use it and get quick decisions. So basically, you can access your model online instantly. You can use your tablet, phone, or a computer. It works both in the field and in the office, and it also works with Ethernet models or MIKE urban models. So what are the challenges that water authorities currently face? So basically, normally the models require technical skills or some modeling skills for someone to actually interrogate the results. So what happens is that decision makers normally rely on consultants, external consultants, to give them answers about fire flow, shutdown planning, simple things that they should be able to get from their model. That process is quite time consuming and it also costs quite a bit of money. So WaterNet Advisor will just allow them to go online, access their model, and get those simple analytics from the model. How it works, basically, there are four main steps that you would go through as a user. So the first step is to set up a one-off time installation of the software in your company server or cloud storage. Each user will have a username and password, and they can just log in online and access their models. Once you log in online, you can access any of the existing models that you've loaded previously or that was shared with you, or you can add a new model in the two formats that I mentioned before. And then you'll be basically ready to run the different scenarios. So currently in WaterNet Advisor, we've got 12 different types of analysis that we can do as a user. Those will help you basically answer questions regarding what is the fire flow capacity in your network, where will the water flow in emergency, what is the remaining capacity. If you would like to isolate a specific pipe, it tells you what sort of valves to close, as well as what would be the impact on the network based on that shutdown. There's also an option of running a contamination analysis where you can load a specific contaminant into the network, and then you see how far and how fast it's spreading. And then also there's a pipe criticality analysis option. So here are just basically a few examples of what you can see from the interface if you run a hydraulic simulation. So you get a quick idea about how your network is actually operating. You get an idea about the bottlenecks in your network, where you have small pipes, areas where you have high or low pressure, and pressure fluctuations as well. Another thing is, as I mentioned, the remaining network capacity. So if there is a new development or a new house to be connected to your network, you can see if you have enough capacity in your network. Contamination analysis is also another one where, as I said, you load a specific contaminant and it uses a heat map to show you how fast and how far that contaminant is spreading over a specific period of time that you choose, let's say around 24 hours. Water age, again, is a very simple analysis that can be done in WaterNet Advisor, and it just gives you a quick snapshot of what is the water age within your network, and where would you potentially have water quality issues. So in WaterNet Advisor, currently you can load a model, an existing model that you know it's working and it's calibrated well, but you can make simple edits such as modifying your pump speed or valve regulation, or even the pipe size or diameter, for example. And then you can run your simulation based on that. So let me give you a quick demo first. So we'll just, yeah, so you just log in online using waternet.dhigroup.com, and you use the username and password that was provided to you. So let me just log in. Once you log in, the system basically takes you to a map where you have the activated model. So as a user, there are three main tabs that you should be interested in. The first one is models, and that's where you can see all of the registered model within your account. Those models can be models that you've loaded or models that's been shared to you by another user. You can also create a new model. So just give it a name, a bit of a description, and it's very important to load to add the correct coordinate system which your model has been projected on. And then you choose the type, whether your model it's a standard water distribution model, it's a WD online that has the online modeling option. It's a collection system, a model where you can interrogate the wastewater, for example, results. And then you choose your file. It's highly recommended to use a zipped file and then load the model through that, because it will be much faster. And then also you can share your this existing model with any other user that you know of in your organization. Normally it takes 1 to 2 minutes. So for the sake of demo, I will not do that at the moment. But currently I have a model which is activated. So let's cancel that. Yeah, and basically the start here shows you that the model is active. If you would like to active any other model, you just click on it and then you click on active. So the next step is the scenarios. That's where you can create a whole lot of different scenarios, and then you can basically run the different analysis in different scenarios. And then the mapping interface. So let's go and create a new scenario here. And let's just call it simulation. So I've created a new one, and now I can activate it. So the mapping interface basically has just very simple things, such as the layers, where you have your background layers, the model components such as tanks, reservoirs, junctions, and pipes. And then also you can have multiple GIS layers that you can load and visualize within the map interface. In here, that's where you can run the different analysis. So what we're interested in first is the hydraulic simulation, hydraulics, create analysis. Let's say we'd want to run it for 1 day, 10-minute time step, and 1 hour report time. You can also obviously go for a smaller time step, but just for the sake of this demo, just gonna do that. And if you are happy with the setup, you can just save the log. So next time when you run a hydraulic simulation, it reloads this setup for you. And then you run. So while this is running, we can go back and create new scenarios just for what we're gonna work on next. And if if we go back to map, we can see that the simulation has finished. As soon as the simulation is done, it basically creates a results layer, and that's called hydraulics here. So what this has basically, it has multiple layers that shows you the condition of your network. So for example, pressure, we can animate the results and see how the pressure changes over the 24-hour period based on our setup. If we run it for longer, it shows us the condition based on the full simulation period. And keeps changing once every hour. A similar thing you can see for demand, flows, and velocity. But very important layers that we have here is the pressure fluctuation. So it shows you the difference between the minimum and maximum pressure during the simulation period. There is also another one called reverse flows, and that's where you can see basically bottlenecks in your network. So if you just have a quick look, you can see here there is red and orange pipes, and that means the water have reverse flows in those pipes more than 5 times if it's red, and between 3 to 5 times if it's orange. So you can investigate this further as an operations engineer or planning, and see if it's relating, for example, to the pipes being having a small size, or is it because it's close to a reservoir, for example. So yep, so this is the hydraulic simulation, but there is also another useful analysis that's called flow tracing, and that basically requires you to select a node. You select one in the middle and create an analysis. So what that will do basically, it shows you where did the water come from into that node, and where is it going to basically. So if we just so orange means it's backward tracing, and green it's forward tracing. So any water that goes from this node it supplies all of this area, and where is it coming from? If you have multiple reservoirs, it's actually quite important to know where your water is being supplied from. So let's go and create a network, go to the network capacity scenario. And then we can create an analysis here. And this one is basically when you know that there is a new development or a new mall, for example, or a new section, and you want to see what is the remaining capacity in your network. So let's just select this node and load it here. See, say the minimum service pressure is 40 meters, maximum is 1. And you'd want to see that at 9 a.m. peak time, basically. So yeah, the simulation runs pretty fast, and it just gives you a number. So that number shows that you have a remaining capacity of 18 liters per second, and it shows you what is the actual pressure based on the model results, as well as the actual velocity and existing demand. You can also go and change it to another hour if you want, or change the minimum service pressure. Yeah, so there's a lot that you can do. Another thing that we can do, which is done in a similar way to the network capacity, and that's the fire flow. So fire flow analysis, you can do that for around 3 nodes. So if we have here a layer called hydrants. Just let it load. But that basically will show you where the hydrants are located. And then you can click on the junctions that are closer to the hydrant and work out the fire flow within that area. So we've got a hydrant there, and then let's say we select this one as well, and that. Visual pressure, let's say again 40, and at 9 a.m. So for flow, you have different types of analysis. So you've got flow for pressure. So you work out the flow for a specific pressure that you specify, or you can work out a pressure based on a flow that you know, or you basically gives you the available flow for a free discharging hydrants. So you run the simulation, and then it will just give you the available flow at each of those hydrants or nodes. So you've got 13 here, 0, that's interesting, but 21 in this one as well. And it gives you a total basically. So if you selected hydrants within one zone, it gives you the total available flow. So these are basically some of the scenarios that you can run. Another one maybe I can do is the shutdown planning. So create one. So save the scenario, and now we're going to activate it. When we go shutdown planning, and we don't need the hydrants now, but we need the valves GIS layer. And let's say we just want to isolate this pipe. And you run it for 1 day, hydraulic time step, and 1 hour reporting time. So since we have the GIS valves added, you can say find GIS valves, and that's basically targeted for field servicemen who basically, if you are using this in a tablet, you can just zoom to your location, and then it shows you what valves to close. So it highlights them for you, as well as you get the IDs as well. So let's say we want to close these valves from 6 to 9. And we just run the simulation right now. What this is doing really, it's running basically a hydraulic simulation, but based on the while this pipe is being closed. And then it shows you the impact on the network. So it created a new results, a bunch of result layers, and it's quite similar to the one that we've had for the normal hydraulic simulation. So if we unselect those valves and the pipe as well, you can click on flow and run the animation. So it's showing that it's green basically, and then as soon as you hit 6 a.m. it becomes red. And when it's red, it means that there is no flow that's going through the pipe. And it also shows you which other pipes have been affected by that shutdown. So those two as well. If we chose a pipe which is located in the middle of the network, then the impact would definitely be much bigger. So what we can do also is that you go to time series and then select a specific pipe. So let's select this one. And then it shows you the flow. So it's from 12 a.m. all the way to 5. It was low because no one was using. And then it goes down to 0 between 6 to 9. You can also select a specific node and add basically add a graph for the pressure. And again, yeah, similar thing. So this is the flow and this is pressure. Pressure was around 50, and then it goes all the way down to 0. And then as soon as the pipe is opened again, it goes back to normal. So yeah, so this is basically a quick demo of what WaterNet Advisor is and what it really offers. But we have all of the different analysis that we can do using the analysis type here. And I just ran you through some of them. So let's go back to the presentation. So that was basically a demo for WaterNet Advisor using the static model that was loaded into it. There is an option for online modeling, and WaterNet Advisor is a prerequisite for it. And that's where your model basically can connect, your hydraulic model can connect with SCADA system for real-time, hindcast, and forecast analysis of your water distribution system of any size. So in summary, WaterNet Advisor is a very user-friendly tool. Currently, we have over 40 users around the world, including New Zealand. Those are spread over 14 countries. And basically, the aim of it is to allow people who do not have technical modeling skills to interrogate the model results, to actually use their models and make quick decisions out of it. So it works with EPANET and MIKE Urban, and it works also in the field as well as in the office. So yeah, thank you for listening, and I really hope you find this useful. If you would like any further information, please feel free to contact me directly or contact Mike at dhigroup.com.